Hi everyone, I want to go over a couple examples from our trig geometry unit with you. The first thing that I want to start with are the special triangles. So this year we learned about a 45, 45, 90 triangle. And make sure that you know the side measurements of this equilateral triangle. That's 1, 1, and root 2. Okay, and then we also have a 30, 60, 90 triangle, which comes from half of an equilateral triangle. So across from 30 is a 1, across from 60 is root 3, and the hypotenuse is a 2. So for instance, we can use these triangles if we're trying to find any kind of SOHCAHTOA ratio, sine, cosine, or tan. So let's say we wanted to find the tan of 60. I would do opposite over adjacent. So I know that the tan of 60 is equal to root 3 over 1, which gives me root 3. Okay? The next thing that we need to know is how to use something called the cast rule. Okay? So if we have our little quadrant grid, remember that this quadrant grid has sides 0, 90, 180, 270, and 360. Okay? Basically, we're just going up by 90 degrees, okay, because each of these are 90-degree angles. Okay, the cast rule starts in the bottom right quadrant, C, and moves counterclockwise to the third quadrant, okay, C-A-S-T. This is quadrant 1, 2, 3, and 4. So the C starts in quadrant 4. Okay, what these represent are basically the words all, sine, tan, or tangent, and cosine. Okay, and these tell us which trig ratios are positive in which quadrants. So from the 0 to 90 quadrant, all trig ratios are positive. Okay, from the 90 to 180 quadrant, the sine ratio is positive. So that means that sine is positive, but cosine is negative, and tan is negative. Okay, so for instance, if you go and try in your calculator right now, cosine of 120, it will be negative, but the sine of 120 will be positive. Okay, in our next quadrant, the 180 to 270 quadrant, only tangent is positive. So sine is negative, cosine is negative, but tan is positive here. So choose any value between 180 and 270, test sine, cosine, and tan for that, and you'll see negative, negative, and positive. Okay, and then the last quadrant, 270 to 360, this means that cosine is positive in this quadrant. So we have sine being negative, cosine is positive, and tan is negative. Okay, so the cast rule helps us basically whenever we have some kind of trig ratio that is over 90 degrees. Okay, and the special triangles will help us for angles that have reference angles of 45, 30, or 60. Okay, so let's take the sine of, I don't know, maybe 225, for instance. Okay, so the first thing that we're going to do is we're going to look on our quadrant graph, and we're just going to place 225. Okay, we just want to make sure that we know exactly where it is. So it's somewhere between 180 and 270, so somewhere around there. Okay, so there's our angle. Like we said, it's between the 180 mark and the 270 mark. Now what I'm going to do is I'm going to kind of make like a right angle triangle with my closest x-axis here. We never want to use the y-axis to create that right angle triangle. It's always x. Okay, and this little slice inside here between the center value, the terminal arm, and the x-axis arm, that's going to be our reference angle. Okay, we also call this a buddy angle. Okay, so if this whole thing, you know what, maybe I'll use another color for that. If this whole angle right here is 225, I basically want to find out what this little blue slice is. And I can do that because I know that this part of it is 180. So I'm going to do 225 minus 180, and that gives us the remaining little slice, which is 45. Okay, so this guy is 45. Okay, so the sine of 225 is going to be equivalent to the sine of 45, except for that we need to decide whether it is positive or negative. Okay, so the sine of 225 is actually in the tan quadrant, and we said in the tan quadrant, sine is actually negative. So this is going to be equal to the negative sine of the reference angle, which is 45. Now if we look back on our special triangles back here, you can see that the sine of 45 is opposite over hypotenuse, which is 1 over root 2. Okay, so this guy is going to be equal to negative 1 over root 2. Great. Okay, we're going to take a look at the opposite type of angle. My goal here is to find both theta between 0 and 360 that satisfy this expression. Okay, now you're going to notice that on your calculator there is no cosecant there. So what we need to do is we need to utilize the reciprocal function of cosecant, and then we can use that on our calculator. Now the reciprocal of cosecant is sine. And if I'm going to do the reciprocal, I have to do the reciprocal of this. So I'm going to take this and I'm going to do 1 over negative 1.269. Okay, and we know to solve for theta, what we need to do is take the sine inverse of this value. Okay, so on your calculator, making sure you're in degree mode, you are going to do the sine inverse of that value, whatever that is. Okay, and I believe that you end up getting negative 52 degrees. Now, looking up here, our theta must be between 0 and 360. So in order to turn this into its positive version of this angle, I'm going to take it away from 360. Okay, so 360 minus 52 gives us 308. Okay, here we go. So that's my first angle. I also know, based on the cast rule, that I have a second angle somewhere. So looking at cast, for me to have a negative sine value, I know my angles must be in the two quadrants where sine is negative. And that is the cosine quadrant and the tan quadrant. We just found the answer in the cosine quadrant, 308. We also found the little reference angle here. And now that I've found this reference angle, which is 52, I know that this reference angle is also 52. Okay, they have to be equal. And this is 180. Okay, so my angle should fall between 180 and 270 here. Okay, and this is 52 degrees past the 180 mark. So I know my second theta is going to be equal to 180 plus 52. Okay, and that ends up giving us 232. Okay, so those are my solutions.